Alright, so this is Pre-E2.4, which is a review of how to solve a system of equations. So the two methods we're going to go over is substitution and addition. And the addition is also called the elimination method. I'm not sure which one it uses in my math lab, so just know addition and elimination are the same thing. Okay. When we solve by substitution, we usually use this method when one or both of the lines, or let's say of the equations, is already solved for a variable. Okay, and I'll just say plug it into the other equation and solve. Okay, so what that means is if I have two equations, say something like x plus 2 equals 4 and y equals 7 plus x, or something like that. Okay, notice this one's already solved for y. So if I know what y is, I can plug it in my second equation. So basically that's why it's called substituting, is because I'm substituting 7 plus x in for the y in the first equation, which would give me an equation that just has x's, which is easy to solve for. Okay, substitution is pretty easy if one of the equations is already solved for a variable. Okay, if it's not already solved for a variable, then we want to go ahead and use addition, which is also called elimination. Okay, when we use the addition method, what we do is we multiply one or both equations by a number in order to make the variable terms opposites. So they will cancel when added together. Whoops, I don't know how to spell together. Together. Okay, so on this one, what we're doing is if we have something like negative 3x plus 2y equals 7, and we have positive 3x minus 5y equals 1, something like that, notice my negative 3x and my positive 3x are opposites. So if I were to add these equations straight down, those would cancel, and I'd be left with negative 3y equals 8, which is something that I can then easily solve. Okay, so that's the whole idea behind addition, is that we're going to multiply one or both of the equations by a number in order to get one of those variable terms to be opposites. So that if we add straight down, we get rid of a variable, or we eliminate a variable altogether. Okay, so that's where we're headed. Let's look at some examples. Based on what form they're in, how they look, we'll determine what would be the best method for solving them. So the first one, it says y is equal to x minus 3 and 8x is equal to 6y. Notice this one's already solved for y. We already know what y is. So if I already know what y is, I'm just going to take that and I'm going to substitute it in for y in my second equation. Okay, so that gives me 8x plus 6 times y, which we know is x minus 3, is equal to negative 74. And then I just solve. So I have 8x plus 6x minus 18, don't forget to distribute that 6 to both terms, equals negative 74. Then I combine my like terms, which gives me 14x minus 18 is equal to negative 74. Excuse me. And then I'm going to add 18 to both sides. So I end up with 14x is equal to negative 56, and then I just divide off my 14. Okay, when I divide off my 14, that leaves me with, okay, so I get negative 4. Okay, so that's my answer for x. Now I want to go ahead and find my answer for y, because when we talk about solving systems, we're looking for the point where these two lines cross. So we know our x value, now we need to know our y value, and we're going to write our answer as an ordered pair. Okay, so once I know x, now I just plug this back into one of my equations. Here, the equation I'm going to plug it into is the top one because it's already solved for y. Y equals x minus 3, so that means y equals negative 4 minus 3, which means that y equals negative 7. And then I just write my answer as an ordered pair. So negative 4, negative 7. Okay, let's look at another way. Now this next one, again, I have, let me see what else I have. Hold on. Okay, so again, notice on this next one that I have one equation that's already solved for y, right? The second equation is already solved for y, so I can plug it back into the first equation. Since I know y is the same thing as this quantity, I'm going to put this quantity in for y into my top equation. So I have 6x minus 9 times y, which we know to be 7x plus 43, is equal to 12. And then I just simplify. So 6x is equal to negative 63x, when I distribute, and then negative 9 times 43, I do not know. I'm going to use my calculator. 9 times 43 is negative 387 is equal to 12. And then I keep combining. 63, negative 63 and 6 gives me negative 57x minus 387 equals 12. Then I'm going to move my 387 to the other side, which gives me negative 57x is equal to 399, and then I divide off my negative 57. And hopefully this comes out pretty. We shall see. 399 divided by 57, ooh, is 7. Good. So we end up with x is equal to negative 7. Now remember, that's not our whole answer. That's just the x part of our answer. So we have to plug it back in to find y. I'm going to plug it back into my second equation because my second equation is already solved for y, which tells me 7x plus 43 is what y equals. So I'm going to put the x that I found, so 7 times negative 7 plus 43. 7 times negative 7 is negative 49, plus 43 leaves me with y is equal to negative 6. Okay, so my ordered pair that solves this system of equations is going to be negative 7, negative 6. Okay. Let's look at a couple more. Now this one, notice nothing is solved. One's not solved for x, one's not solved for y, so I'm not going to use substitution. Now it would be easy to solve one of these for x or y, but I'm going to go ahead and use elimination just so you see how it's done. Okay, I look at my x's, which are not together, and I look at my y's, which are not together. So that's the first thing I want to do is rewrite these with the x's lined up and the y's lined up. So I'm going to write this as x plus 6y equals 21. And then I'm going to rewrite this one with my x first. Negative 4x plus y equals negative 9. Now I'm going to go ahead and make my x's opposite. I'm going to go ahead and just say make x's opposites. Now, you can choose x's or y's. It doesn't matter. In order to make these two terms opposite, I would have to multiply this one by a positive 4. So that's what I'm going to do. Okay. So when I multiply this top equation by positive 4, I get 4x plus 24y equals 84. 84. And then my second equation, I'm just going to leave the same. I don't need to change it. Okay. And now look, my x's are opposites. So I'm going to add my two equations straight down, which when I do that, my 4's cancel, and I'm left with 25y is equal to 75. Yes. Okay. And then I just need to solve for y. So I divide off my 25, which gives me y is equal to 3. So I have my y value. Now I just need to plug back in and find my x value. Okay, it doesn't matter which one you plug it into. I'll go ahead and plug it into the top one because I'm solving for x, and here x is pretty much simplistic on that one. So I have x plus 6y is equal to 21. So I do x plus 6 times y, which I know to be 3, is equal to 21, which means that x plus 18 equals 21. And when I move my 18 to the other side, that means that x equals 3. Okay, so the ordered pair that solves this system is the point 3, 3. Make sure you write your answer as an ordered pair. Okay, so all we did was rewrite it with our x's lined up and our y's lined up, and then we multiplied by one of the equations to make sure that one of the variables were opposite so that we can eliminate it. Let's look at another one like that. On this next one, we have opposites. Now notice we could do x's or y's. If we want to make the x's opposite, I would just need to make this one a negative 3x, right? If I wanted to make the y's opposite, I have to find the least common multiple. So the smallest number that 4 and 3 go into would be 12. So I would have to multiply this one by 3 and the other one by 4. So that's a little bit more work. So I'm going to go ahead and just clear my x's again. Okay, so I'm going to make my x's opposite. So do whichever one makes it the easiest. So if I want to make my x's opposite, that means I need to multiply my top equation by a negative 3. I need it to be 3x, and I specifically need it to be negative so that those will cancel out. Okay, so I'm going to go ahead and multiply that top one by negative 3, which will give me negative 3x minus 12y is equal to negative 75. And then I rewrite my second equation, which is 3x plus 3y equals 12. So notice my 3x's cancel when I combine straight down, and I'm left with negative 9y is equal to negative 63. And then I just divide off my negative 9. When I divide off my negative 9, I'm left with y equals positive 7. Now that I know what y is, I just plug it back into one of my equations to figure out what x is. So I'm going to plug it into the top one just because x doesn't have a coefficient in that one. It really doesn't matter which one you plug it into, you'll get the same answer either way. So I have x plus 4y, which we know is 7, is equal to 25. So x plus 28 is equal to 25. I move my 28, which means that x is equal to negative 3. So the ordered pair, the point in which both these lines go through would be the point negative 3, 7. Okay, so that is the end of Pre-E2.4. Your assignment for Pre-E2.4 is a regular quiz on my math lab. And let me know if you have any questions or problems. I updated the lecture schedule and the due dates are posted on it. Okay?